Have you ever wondered why in the world do we do this? Pounds, grams. Pounds, grams. Why? Great, mighty King Henry died drinking chunky malted milk at night. The System International, or SI units, you probably know it as the metric system. So let's start off with a mnemonic that'll help you remember all the prefixes that we want to use in this lesson. Great mighty King Henry died drinking chunky malted milk at night. Let's do it 2 more times. Great mighty King Henry died drinking chunky malted milk at night. And 1 more time. Great mighty King Henry died drinking chunky malted milk at night. We'll make the first letter of each of these words red. That'll help us remember that the first letter will be applied to the first letter of the prefixes. Giga, mega, kilo, hecto, deca, deci, centi, milli, micro, and nano. Each of these prefixes has its own symbol. Giga is capital G, mega is capital M. Kilo is lowercase k, hecto is lowercase h, deca is lowercase da, deci is d, centi is lowercase c, milli is m, micro is the Greek letter mu. It looks like a U with a tail. And nano is a lowercase n. Next, we'll do the exponents, also known as scientific notation, but we'll learn more about that later. Notice as we go down that we don't always change by 3 decimal places. When we get to kilo, we just change by 1 decimal place, and we continue doing that until we get down to milli. Then when we get to micro, we once again change it by 3 decimal places. Each of these has its numerical value. Giga is 1 billion, mega is 1 million, kilo is 1,000, hecto 100, deca is 10. As you can see, 1 has no prefix, no symbol, and no exponent. Then we get to deci, it's 0.1. 0.01 is centi, 0.001 milli, and then we get to 1 millionth and 1 billionth, and that's micro and nano. We live in a first world country. So why in the world do we not use the metric system? It's the international language of science. Do you know that there's only 2 countries besides us in the whole world who don't use it? Liberia and Burma. Why? So now let's talk about the base units that you will frequently find in the metric system. For mass, we use kilogram. So we would use the symbol kg. For length, we'd use meter. That's lowercase m. For time, we'd use seconds. That's s. For temperature, we'd use kelvins, capital K. For amount of a substance, we would use moles, M-O-L. For electric current, amperes, capital A, and luminous intensity, candelas, that's CD. Would you want to use 14 numbers to solve a complicated math problem or science problem if you could just use 3? 14 or 3? 14 or 3? Which one would you want to do? 3. If you pick 14, I have 2 questions for you. Number 1, why? And number 2, what's wrong with you? So now let's do some practice questions to see how much you've learned. You want to have pen and paper handy. Get ready to pause the video after every question. So the first one is 9,500 grams is how many kilograms? The next one is write 4.5 megameters as meters in scientific notation. And the next one, What name would you give to 10 to the negative 6th seconds? Next, write 1.4 nanograms as scientific notation. How would you name 10 to the negative 9 meters? And the final one, how would you name 4.1 times 10 to the negative 3rd seconds? So next, let's learn about scientific notation. Take the example 0.000000142 meters. As you can imagine, writing out numbers like this is extremely inconvenient and time-consuming. That's why we use scientific notation, so we can write long numbers like this in a shorter form. So what we need to do is make that 1 be just to the left of the decimal point. In order to do that, we count how many decimal places it'll take, and we can see that it's 7. And since we're moving the 1 to the left, it'll be to the negative 7th. So that's 1.42 times 10 to the negative 7th meters. So now let's look at another example. 142 billion. So now we'll do the same process, but in the opposite direction. This time, we'll count how many decimal places it takes for the 1 to move to the right so that it can be just to the left of the decimal point. And we see that it's 11. So that gives us 1.42 times 10 to the 11th power meters. Now I'm going to give you an example to try on your own. Pause the video here and see if you can work this one out. You should have counted 5 decimal places to the left so that you can have the 5 just to the left of the decimal point. And that would have gotten you 5.48 times 10 to the negative 5th meters. Next, let's learn about conversion factors. Conversion factors are important because they allow us to convert one unit that's not an SI unit into something that is an SI unit. So for example, how many kilograms are in 3,400 pounds? The first step is we write out what's called a conversion factor. A conversion factor is simply stating what one unit is equal to in another type of unit. So, for example, 1 kilogram is equal to 2.2 pounds. Therefore, we could say 1 kilogram divided by 2.20 pounds is equal to 1. And conversion factors are always equal to 1. It's important to remember that the numerator, 1 kilogram, must be what's known as the desired unit. The desired unit is the one that you're trying to find, and that the denominator, which is in this case 2.20 pounds, is the known unit. It's the known unit because we were already told that we have 3,400 pounds. The next step is we write out the formula that'll help us solve this problem. We simply multiply the given units times the conversion factor. Our given unit is 3,400 pounds, and we multiply that by 1 kilogram divided by 2.2 pounds. Then we eliminate the like units, which is pounds, and we're left with a simple division problem. We simply multiply 3,400 times 1, and then we can divide it by 2.2. And that gives us our answer, our desired unit, 1,545 kilograms.